So we're being asked to write a quadratic in vertex form, and the first thing you might be wondering is what exactly is vertex form? Well, let's start with this. This is standard form. And when you have it in standard form, you have clearly marked an x squared, an x, and a 48, and it's great for, it's just how you usually end up seeing things. But vertex form is the form where we're going to have something more like, and this is not the correct answer to this problem, but something more like just one kind of x encased in a parenthesis with another constant. It'll be squared, and then we might have another number on the outside over here. So like they're saying over here, and there may be a number in front as well. So there'll be a multiplier out in front, some kind of just one single quantity squared, where we have x plus or minus some value, and then something in the front. And the reason why we call this vertex form is because what we should hopefully know by now is a parabola, if it's just plain old y equals x squared, we know it's a U-shaped graph called a parabola. And we saw in previous notes and examples that this graph would be a graph that would shift right 3 and up 5. So if you can imagine this parabola right here shifting 3 to the right and up 5, it would look like this instead, and we'd have like the vertex would just move to there, and that's why we call this vertex form, because we could look at this and say right away where the vertex is. But here's how we actually get something in that form. It's going to look like this. Well, we're going to do that completing the square business that we did earlier. And when we did completing the square, one of the tricks was to make sure that the coefficient on x squared was equal to 1. So we're going to focus our attention. We have 2x squared minus 20x plus 48. I want to get an expression where I've got something squared. I need to complete the square. I need to kick that off by getting this 2 out of the way, because I can't complete the square very easily if there's a coefficient on front of x squared. So I'm going to factor this 2 out, but not out of everything, just out of these first 2 terms. This I'm going to leave alone. So what I'll be writing down is f of x equals, let me pull that whatever that coefficient is, pull that out, open up a big parenthesis, and what's left inside is the x squared, for sure. If I take a 2 out of here, I have negative 10x. And now I want to throw a blank in there so that I can complete the square. But if I'm going to add a blank, I also have to subtract that some kind of value to keep things balanced, and that 48 still hanging out over here. So what you're basically seeing here is, you know, the 2 is pulled out. This would give me 2x squared. This would be negative 20x. So I have that portion. The 48 is still here. And I'm going to go ahead and also I'm going to have to find a correct value to put here and put a balancing number over here that'll work out. So what number goes in that blank? Well, when we complete the square, we know we want to take half of this number and square it. Now that's supposed to look like a 10. Half of 10 is 5. 5 squared is 25. So I'm going to put a 25 over here. And now before you rush off like crazy and start putting 25 here as well, you got to be a little careful. Because this 25 is in this big fat parentheses, and there's that 2 chilling out. So I didn't just add a 25, I actually added 2 times 25. And that's what I have to subtract to keep this thing balanced. That's why over here, when I subtract something, it's going to be a 50. Now, this looks a lot worse. I'm not going to lie. I don't feel better at all. But it's about to look a billion times better. So this portion that we just figured out, well, the whole point of this was to complete the square. We know from our sections on completing the square that I can rewrite this part as x with a minus, and then it'll be whatever half of this is, or whatever this square root is, it'll be 5 squared. This 2 just comes on down, and then these are like terms that combine to make negative 2. So now what I have is a brand new function. No, it's the same function, excuse me, written in a different form. It's called the vertex form. And we can look at this and know, oh, this would be a parabola, a U-shaped graph. I know that because it's got the squared over here, and it'll be shifted 5 to the right and down 2. So the vertex that's normally at 0, 0 would be shifted 5 to the right and down 2. So that vertex must be at positive 5, negative 2. The last little caveat I want to mention in this long video is that it's always the case that whatever value of x makes this 0, that's your x value. So if they say negative 5, the x value is actually positive 5. If it was, say, like x plus 7 squared, then my x value would be negative 7. And then this number is what it is. So the y value is whatever that actually is. So just like the left-right things are opposite of what you'd think, and the up-down is what you would think, this vertex thing works the exact same way because it's based off the same idea. It's based off the shifts. I'll do the next one with less chattering. I'll just kind of go right through it and do it. So good luck on this. Stick with it. Be patient. Keep the following things in mind. We got to get there to be, if there's a coefficient on x squared, you got to pull that out. You're going to complete the square with what's left inside and then balance things out. You'll see a nice, concise explanation on the next one with less yammering. So please watch that one too. Thanks.